Day 76, Honors Physics, Universal Gravity, problem number 24. We're looking for the acceleration due to gravity on the surface of Jupiter. So it's not 9.8 meters per second squared like it is on Earth, well, unless it's by coincidence. But the idea is, as I showed you in class, the general force of gravity, your weight, W equals mg. Force of gravity is your weight. And then the more universal equation, force of gravity, your weight, equals gmm over r squared. Once again, you can only use this equation if you know your value for g on the particular planet you're on, which we know for Earth is 9.8, so we can use that all the time on Earth as a shortcut. But anyway, if we set these two equal to each other, this, mg, equal to the universal gravity computation. This little m here is your small mass, not the mass of the planet. M sub 1 is the mass of the planet. So we have this equation here that we can use universally to figure out the acceleration due to gravity of a planet on its surface if we plug in the radius of the planet right here for r. Or we can find g at any distance from the center of the planet. So for example, on Earth, this is 9.8 on the surface, but if you go up higher than the surface, the further out you go, if you double your distance from the center of the Earth, in other words, go 1 Earth radii off the surface, so you're twice as far from the center of the Earth as you were, your gravity is going to be 1/4. So if you double this and square it, you get 1/4 the strength of the gravitational field. So instead of like 9.8 or 10, it'd be about 2.5 meters per second squared acceleration due to gravity if you're 1 Earth radii off the surface. That's about 4,000 miles up, straight up. Of course, we never really go there except for some astronauts. But on the surface of the Earth, it stays pretty consistent at 9.8. It fluctuates a little bit because there's some mountains and valleys and so forth and other issues. But for the most part, it's 9.8 meters per second squared. But in this case, we're plugging in the mass of Jupiter. This is Jupiter, right? Yeah. That gives you that. Kilograms is what we want. That's the only unit in this class where we're going to stick with the kilograms as our standard. Kilo or mega or milli or anything. This is the only one that's got a prefix, kilograms. We want meters, though, for the distance. And they gave us kilometers. So you'll notice here, I hope, that I added 3 more zeros onto this because kilometers is 1,000. 3 more zeros onto the 4 zeros that are there. 10 to the 4th plus the kilometers gives me 10 to the 7th meters. Just plug those in. Once again, make sure you square this number. Don't just square the 7. Square the whole number. In fact, if you square the 7, you get a wrong answer. And that should do it for you.